Spark Academy. We are doing short questions of intermediate first year. We have to do last but one chapter, mechanical properties of solids. One question I have to do, very important question. Next, I have to do last chapter, thermal properties. That is short questions. In that, 3 important short questions are there. Let us start today with the question on mechanical properties of solids. Last 2-3 days back, I did strain energy derivation. That is the important derivation we did, strain energy. One more question is there. Explain the behavior of wire. Explain the behavior of wire. Explain the behavior of a wire. Behavior of a wire under gradual increasing load. Under gradual increasing load. Gradual increasing load. This is the question, 4 marks question. So generally, wires are elastic in nature. Wires are elastic in nature. Whenever it follows Hooke's law, stress versus strain. What is stress? Load by area, force by area. What is stress? Force by area or load by area. What is strain? Longitudinal strain means change in length by original length. So stress versus strain. We'll imagine that a wire is suspended. A wire is suspended from a rigid support. A wire is suspended from a rigid support, and at other end, a wire is suspended from a rigid support, and other end, a load is attached. A load is attached. The load is increased. There is a gradual, we have to do gradual increase in load. Now we have to attach a load and we have to see. We have to do gradual increase in load. Gradual increase in load. Gradual increase in load. And its behavior is studied by graph. Behavior is studied by graph. A wire is suspended. Let us say there is a wire. You are suspending a wire and you are attaching a load here. You are attaching a load. You are go on increasing load. This is the elastic wire. This is the elastic, let us say steel wire. You can take steel wire like that. Example. Elastic steel wire. Gradually you are increasing load and you are seeing what is the behavior. Behavior, how you are seeing behavior? By graphically. I am drawing a graph in the next page. I am drawing a graph in the next page. What is the graph? Stress versus strain. I am drawing a graph. Stress means load. Load by area. Go on increasing load. If you increase load, what will happen? It will extend. If you remove the load, it will get back its original length because it is elastic nature. When you increase load, wire length will increase. If you remove the load, it will come back to original length. That is Hooke's law. But after stage of Hooke's law, what will happen? You have to study. This is a ductile material. This is strong material like steel wire. So I am drawing a graph. I am showing the graph in the next page. The graph I am showing in the next page. I am showing the graph in the next page. So graph is what? I am showing the graph. I am showing the graph. stress versus strain. You have to write what you are taking in y-axis. Stress versus strain. This is the graph. What is the graph we are going to get? What is the graph I am going to get? First I will get a straight line graph. It's called proportional limit. This is called proportional limit. Thereafter it gets curved slightly. This is called elastic limit. Thereafter you get yield point. Thereafter, like this. This is a tensile point we'll get here, T. Tensile point. This is called breaking point. Breaking point. So we'll change the name here. We'll change the names here. I'll change the points here. This is proportional limit. This is elastic limit. This is elastic limit. Elastic limit. This is yield point. Yield point, tensile point. So here I'll write one by one. I think this is clear. This is E. This is called E. What is what I'm telling you? What is P? Proportional limit. P is called, 1 minute. P is called proportional limit. P is called proportional limit. What is what? I'll tell you and write. P is called proportional limit. E is called elastic limit. E is called elastic limit. Then Y is called yield point. Y is called yield point. T is called tensile point. T is called tensile point. B is called breaking point. B is called breaking point. B is called breaking point. B is called up to P is a straight line actually. Up to P is a straight line. At yield point, if you withdraw, at yield, this is called O. At yield point, if you withdraw force, this is called O dash, permanent set. This is the graph, behavior of wire under gradual increasing load, behavior of wire and gradual increasing load. This is the graph. Okay, students, one by one, what is the meaning of proportional limit? Hooke's law is exactly valid. What is Hooke's law? Stress is proportional to strain. How much stress will increase, that much strain will increase up to P. OP is a straight line. OP is a straight line. P is called proportional limit. Up to P, Hooke's law is valid. Up to P, Hooke's law is valid. After E, P, it is exactly will not obey Hooke's law. Up to P, exactly obeys Hooke's law. Property of elasticity is valid. What is elasticity? Property of regaining original state. If you remove load, it should get back its original length. For example, you will take 10 centimeters length. If you increase the load, it will become 10.7 centimeters. But after withdrawing load, again it will get back its 10 centimeters original length. Up to proportional limit. Beyond proportional limit, what will happen? Hooke's law is not exactly valid. Stress is not proportional to strain. Still, the property of elasticity is valid. It is extending of 10.7 to 10.9. If you remove the load, again get back its 10 centimeters length. Up to elastic limit also, elastic property is there. But Hooke's law is not valid. After that, it becomes softer. So partially loses elastic nature. Between E and V, Y is called what? Yielding point. Y is called yield point, means between elastic limit and yield point, temporarily it loses elastic nature partially. It loses elastic nature partially beyond elastic limit. What will happen is, after elastic limit, it loses elastic nature partially and it will not follow Hooke's law and you lose elastic nature at yield point. At yield point, what will happen? If you withdraw load, it won't get back its original length. For example, 10 centimeters original length is there. If you remove the load, it won't get back 10 centimeters length. It will get permanent strain. OO dash is called what? OO dash is called, I'll write here, what is OO dash? OO dash is nothing but, OO dash in this diagram I'm writing. What is OO dash? Permanent strain. O dash is nothing but permanent set or permanent strain, OO dash. So it won't pass through organ. So I'll write, I think you understood. Now I'll write about what P is proportional limit. So I'm explaining about first proportional limit. First point is called what? Proportional limit. Proportional limit. It's called proportional limit. Proportional limit means proportional limit. Proportional limit. So up to the point A, up to point P, up to the point P in graph. So up to point, what is the graph? Stress versus strain graph. This is the graph. Stress versus strain graph. This is what? Stress versus strain graph. This is what? Stress versus strain graph. Stress versus strain graph. So stress versus strain graph. Proportional up to point P in the graph. Hooke's law is exactly valid. Hooke's law is exactly valid. Proportional limit. Hooke's law is exactly valid. Up to proportional limit, Hooke's law is exactly valid. Okay, students, this is proportional limit. Proportional limit P. Then next, elastic limit. Elastic limit. Elastic limit. After the stage of proportional limit, after the stage of proportional limit, after stage of proportional limit, Hooke's law is not exactly valid. Hooke's law is not exactly valid. Hooke's law is not exactly valid. But property of velocity is there. It would regain its original length. But property of elasticity is there. Property of elasticity is valid. That is under elastic limit. Elastic limit means it gets back its original length here. That is called elastic limit. Of the stage of proportion to Hooke's law is not exactly valid, but property of velocity is valid. Property of velocity means what? It should get back its original length after removing the load. That is happening. Okay, see once again the graph. I'm showing you the graph. Students are getting moved. Please see the graph, students. Please see the graph. All of you see the graph, student. I kept graph very clearly to you. Stress versus strain. Compulsory you have to write y-axis stress, strain. Otherwise you lose marks. You write all these points. Okay, students. Okay, 1 minute. This is yield point. This is called yield point. What is this point? Y is called what? Y is called what? Yield point. Yield point. T is called what? Tensile point. Tensile point. So B is called breaking point. B is called breaking point. O is permanent set. This is called breaking point. BREAKING. Breaking point. Sorry. BRA. I think you understand. Breaking point. Please keep this graph in your mind, student. Keep this graph in your mind. Graph in mind. Next page I'm writing what is yield point. What is yield point I'm writing here. So you can imagine the graph. The graph is there. Next third one is called yield point. Third point is called what? Yield point. Yield point. Yield point. What is yield point? After students, after elastic limit, further load is increased. Further load is increased. It loses. Wire loses elastic nature partially. While loses elastic nature partially. While loses elastic nature partially. Yield point. After elastic limit, further load is increased, wire loses elasticity partially. This is yield point. The point Y is the point Y is called yield point. Yield point. Yield point. At Y, if load is withdrawn, we get OO dash as permanent strain, OO dash as permanent set, permanent strain or permanent stretch, permanent strain. Friend, permanent strain, we get permanent strain, yield point. At yield point, when you withdraw force, after elastic limit, further load is increased, wire loses elastic nature partially. The point Y is called yield point. At Y, if the load is withdrawn, we get OO dash as permanent strain on the x-axis. So because it will not get back its original length, wire cannot get back its original length. For example, original length is 10 centimeters. At yield point, it becomes soft. It won't get back its original length. 10 centimeters means it comes only up to 10.2. It will remain at 10.2. That means that 0.2 centimeters is permanent set. Next, this is called tensile point. Next is called tensile point. Tensile point T. Tensile point T. After yield point Y. After yield point Y, with a little increase in load, yield point with a little increase in load, wire extends permanently. Wire extends permanently. Wire extends permanently, losing elastic nature. T is called ultimate strength. T is called tensile point. Ultimate strength of the material. T is called tensile point. This is last tensile point. So till this wire will be, so this is important portion is between yield point and tensile point. After yield point, it gets extended like anything, goes to plastic strain. It loses elastic nature completely, goes to plastic state. The strength of the material is maximum. T is called tensile point. Last point is called breaking point, student. Last point is called breaking point. B. B is called breaking point. B. Beyond tensile point, T, wire gets cracks internally. Cracks inside, we get breaks. Cracks internally, and finally, wire gets cracks internally with a little increase in load. With little means no increase in load. If you touch it with little increase in load, with increase in load, and finally with little increase in load, and finally wire breaks. At B. This is called behavior of wire and increasing load. Wire gets cracks internally internally with little increase in load, you are not just small increase in load, it gets cracks because it becomes so soft, it become tired, wire gets tired, just like person who is getting tired by working very like that. The wire also gets beyond this load, it gets tired, it gets cracks inside, finally it breaks. This is called behavior of where gradual increasing load. If you take steel wire or copper wire, this has got practical importance between yield point and tensile point. There is a lot of uses there practically. This is the important 4 marks question, student. Behavior of wire and gradual increasing load. More than 50% they are giving strain energy. Other question is gradual behavior of gradual increasing load. Remaining 1 or 2 definition, define Young's modulus, bulk modulus, like that, define stress and strain. If you learn it, it is better. But these 2 questions, Akka, it is coming for 4 marks questions, mechanical properties of solids. There are 2 questions are there, 1 short question will come. I am going to next question, short questions, thermal properties to it. Next chapter is nothing but what? Thermal properties. Thermal properties, short questions are there. Thermal properties, short questions. What is thermal properties, short questions? There are 3 important questions in thermal properties. What are they? Thermal properties. Pendulum clocks, first question. Very easy question. Thermal properties. Pendulum clocks go fast in winter. Go fast in winter and slow in summer. This is asked. Slow in summer. Now summer is approaching, right, students? Now winter is going, summer is approaching. Temperature will increase. Pendulum clocks go fast in winter and slow in summer. Why? This is important question for us. This 4 marks question. So how to do this? Pendulum clocks means, this is a clock. Metal rod will be there. This is a pendulum clock. Pendulum clock made of metal. Bob, pendulum bob here. Handle and all that. So time period. Pendulum clocks, time it is showing. Is it going correctly or not? We should see. Sometimes in a day it loses some seconds, 10 seconds or 5 seconds or 15 seconds. That means it's going slow or fast. So time period of how to judge. Winter means what? Summer means what? Normal temperature means you take 25 degrees centigrade or 30 degrees centigrade. Summer means 42 degrees centigrade. That means suddenly there is an increase in 15 degrees centigrade temperature is there. 25 is initial temperature, finally is 42, about 70 degrees centigrade is there. What will happen? So here this is called length actually. At a given place I am doing. Time period of pendulum, answer. Time period of pendulum, pendulum clock T is given by, in oscillations chapter. That is, of course, the thread is there, here metal is there. That's all. 2 pi square root L by G. 2 pi square root L by G. This is the formula, time period. It says that at a given place means G constant. At a given place, T is proportional to. At a given place, 1 minute, students, time period. At a given place, okay, students, at a given place, 2 pi is constant, G is constant, T is proportional to root L. Length increases, time period increases. Length increases, time period increases. In summer, what will happen? First, you are writing in summer. So as temperature increases, As temperature increases, length increases. Length what? Length of the pendulum. Length L increases. Length of the pendulum L increases. L increases. In summer, as temperature increases, so first you have to extend winter, right? Okay, we'll rub off this. We'll write winter first. In winter, A bit. In winter, first we'll write winter. In winter, what will happen winter? Normal temperature 25. Now let us say in winter it goes to 12 degrees 13. In winter, as temperature decreases, in winter as temperature decreases, length L decreases. So time period decreases. Because time period proportion to L, temperature decreases, length decreases, so time period decreases. Time period decreases means what? Time taken to complete one oscillation is decreasing. Time period is decreasing. Time period decreases. So what will happen? Time period decreasing means clock is going fast. Why it is going fast? Clock is going fast in winter. Going fast in winter means gains time. It gains time. In winter, as temperature decreases, length decreases, its time period decreases. Time period decreasing means what? Time taken to complete one oscillation is decreasing. That means number of oscillations in a day is increasing. So it gains time. In winter it gains time. So you remember time period proportion to L here. Then summer what will happen? This is A bit. In summer what will happen? So B bit. In summer what will happen? In summer, as temperature increases, length increases. Therefore, so time period increases. Time period T increases. Y means T proportional to root L. There also you can write time period increase. So time period is increasing means it is taking more time to complete one oscillation. So clock goes slow. Clock goes slow. It loses time. In summer, it loses time. In summer. So pendulum clock goes fast in winter, slow in summer. This is a very, very important question. I think you understood. Mainly T proportion to root L, you have to tell. Monday. So students, second year, as practicals are going on now, actually we thought of starting in this week, second year course questions, but second year practical schedule was there up to 21st or 22nd. So we are starting on from Monday onwards, second year questions. Start with very short questions on Monday, okay? Next question, explain conduction, convection, radiation with example. Explain conduction, convection. Explain conduction, convection, radiation. Explain conduction, convection, radiation with examples. This is another question. This is important question. Conduction. So this is regarding heat transfer. First, I am telling about conduction. What is conduction? Iron rod gets heated. Iron rod is a conductor. If one end of rod is heated, one end of rod you are heating, other end if you touch, relatively it is also, even though it is not that much hot, heat will be transmitted from one end of the iron rod to other end. Iron rod or silver rod you are taking, or aluminum rod you are taking. So what is the conduction in solids? Heat transfer in solids, that is like metals, because metals are good conductors. Heat transfer in solids like metals by the vibrations of particles, by the vibrations of the heated particles is called conduction. In conduction, there is no movement of molecules. In conduction, there is no movement of molecules. There is no movement. Molecules will not move. There is no movement of molecules. There is no movement. Molecules will not move. Heat transfer in solids by the vibrations. Particles will vibrate, amplitude will increase. Particles will vibrate, energy will be transferred. Heat energy will be transferred from one point to other point. So, by vibrations of particles, heated particles is called conduction. This is in solids, mainly rods. Example is, so heating of metal rod like this. Heating of metal rod, I am heating one end, other end. This is hot end. This is hot, this is cold. This is cold. Metal rod. Heating of metal rod. Example is what? Heating of metal rod. Heating of metal rod by conduction. This is example conduction. I am telling about convection. I am writing in separate page because technical difficulties there. I am doing in next one. Second one is called what? Convection. What is convection? You know, you are heating water in a stove. What will happen? In water, molecules will move. Heated molecules will move up, cold molecules will come down. That is called movement, by movement of molecules. This is called convection current. That is natural convection. The land breeze, sea breeze, trade winds, monsoons, all these are all convection. What is convection? Medium is necessary conduction, convection. Heat transfer in fluids. Fluids means liquids and gases. Fluids means liquids and gases. That by movement of molecules. By movement of molecules. In solids, we told without movement of molecules. Here you are telling by movement of molecules. One is called convection. Sir.
Can you able to read this?
If you prepare 1.5 important maths, student physics and chemistry.
55 pages.
1.5 and 1:5. Vishwanath, be clear what is 1.5 important means what. So whatever students, Vishwanath, whatever questions we are telling, I think you are hearing videos, YouTube lectures. I'm experienced. Whatever questions is there, more than 90% if you read, definitely 55 plus you will get it. So we are discussing according to blueprint only. In the blueprint also, most of selected questions only I am doing 90%. 10%, 15% I am leaving. If anything doubt is there, please again keep clearly what is 1.5 didn't Understand. So you told if we prepare 1.5 important question, 1:5, 1:5 important question can be 1:5 means how we will get 55, no? 1:5. You have to read. So let us say now of course, now today I will end long question, students. After ending long questions, I will tell you finally first year, I'll give data to you. So here you answer.
Like, sir,
They give 5 questions. Give 5 questions. So not clear. Once again, you ask him to give.
like, sir, they give first question in that they give 5
You
questions.
like, sir,
So
first
one-
question that
next
give
one,
5 questions, so one is gone.
come in exam.
నాకు అర్థం కాలే ఆయన చెప్పింది నాట్ క్లియర్. నేను చెప్పను టైం అయిపోతుంది. ఐ అగైన్ ఆన్సర్ ఇట్, విల్ ఆన్సర్ ఇట్. Heat transfer in fluids by movement of molecules is called convection. Example, heating of water. Heating of water. Next, land breeze. Land breeze. Sea breeze. Sea breeze. Etc. Monsoons, etc. We are giving convection examples. Third, radiation. I'm telling about radiation. Heat transfer. Heat transfer. Heat transfer. Heat transfer from one place to other place. One place to other place. One place to other place. Without necessity of medium. Without necessity for conduction, convection, we need solid and liquid gas. But heat transfer movement from one place to other place without necessity of medium. That is in vacuum. In vacuum. Heat transfer from one place to other place without necessity of medium in vacuum is called radiation. It's called radiation. Sun's heat reaches the earth. What is the example? Sun's heat reaches the earth. What is the example for radiation? Sun's heat. Sun heat. There is vacuum is there. Sun's heat reaches the earth. Reaches earth by radiation. Sun's heat reaches the earth by radiation. Radiant heat can pass through vacuum. Out of all these three processes, radiation is the fastest process. Radiation is the fastest process. I think you understood conduction, convection. They are asking this one also number of times. Last question, last short question is anomalous expansion of water. Anomalous expansion of water. Before that, one more question is there. Students, one more question. Explain Celsius and Fahrenheit scales. They are asking this one also. Explain Celsius. Explain Celsius and Fahrenheit scales. Explain Celsius and Fahrenheit scales. Scales of temperature. Scales of temperature. Explain Celsius and Fahrenheit scales of temperature. Obtain the relation between them. Obtain the relation. Obtain the relation between Celsius and Fahrenheit. Between Celsius and Fahrenheit scales. Celsius and Fahrenheit scales. Fahrenheit scales. Fahrenheit scales. Fahrenheit scales. Fahrenheit scales. So students, I am writing about first Celsius scale, student. Celsius scale. Celsius means centigrade. Celsius means centigrade. Here lower fixed point. What is lower fixed point? There is a lower fixed point, melting point of ice. That is nothing but 0 degrees centigrade. This is called melting point of ice. Melting point of ice, pure ice. Upper fixed point, 100 degrees centigrade. That is boiling point of water. Boiling point of water or steam point. Boiling point of water or steam point. So this is Celsius scale, lower fixed point, upper fixed point. If you take Fahrenheit scale, degrees Fahrenheit, here lower fixed point. What is the value of lower fixed point? Lower fixed point is 32 degrees Fahrenheit. Upper fixed point is 212 degrees Fahrenheit. But what is the range of Celsius scale? Range of Celsius or centigrade scale. 100 minus 0, 100 degrees centigrade. Range of Fahrenheit scale. Nothing but Fahrenheit scale, nothing but 180 degrees Fahrenheit. 180 degrees Fahrenheit. Do you understand? So how do you relate them? C minus lower fixed point by upper fixed point minus lower fixed point. 100 minus 0 is nothing but F minus lower fixed point 32 by 212 minus 32. Therefore, C by 100, you are going to get F minus 32 by 180. That is the relation between centigrade and Fahrenheit. If I simplify it, C by 5 is nothing but F minus 32 by 9. I'll get C by 5 is equal to F minus 32 by 9. Simplified relation. C by 5 is equal to F minus 32 by 9. So I want to relate Fahrenheit and this one. What will happen? 9C by 5. Nothing but equal to F minus 32. Fahrenheit is nothing but 9C by 5 plus 32. Fahrenheit is nothing but 9C by 5 plus 32. So I'll show once this one to you completely at a place and draw a graph. So students, you see here Celsius scale, Fahrenheit scale you are seeing here. Lower fixed point, melting point of ice, upper fixed point, boiling point of water. Here also Fahrenheit is scale, also lower fixed point, melting point of ice, upper fixed point 212 degrees centigrade, range of Celsius scale 100, range of Fahrenheit scale 180. So what is the relation? C minus 0 by 100 minus 0 is F minus 32 by 212 minus 32. C by 100 is equal to F minus 32 by 180. To simplify it, C by 5 is equal to F minus 32 by 9. 9C by 5 is equal to F minus 32. So therefore, F minus 32, F is equal to 9C by 5 plus 32. So if you draw a graph, I'm drawing a graph here. I'm drawing a graph. Fahrenheit versus centigrade. This is centigrade. Fahrenheit versus centigrade. You are having a straight line. This is 32 degrees Fahrenheit. Okay, friends, this is 0 degrees centigrade. Okay, this is 100 degrees centigrade. This is nothing but 100 degrees centigrade. This is 100 degrees centigrade. So this is 212 degrees Fahrenheit. This is Fahrenheit. So this is nothing but 212 degrees Fahrenheit. So this is the relation. So this is in the form of y is equal to mx plus c. I am showing you this form of y is equal to mx plus c. Y, Fahrenheit, y-axis, x-axis, 9c by 5 plus 32. But if we cannot write this equation up to this, you write graph, you can draw, you draw the graph. This is the graph you have drawn. This is the graph you have drawn. I'm showing the graph here. This is the Fahrenheit versus centigrade. Okay, students, this is the relation Celsius and Fahrenheit scale. This is relation between Celsius and Fahrenheit scale. Last question, short question is, in what way anomalous expansion of water is advantageous? In what way, last question, last short question is, in what way anomalous expansion of water, anomalous expansion of water is advantageous, for aquatic animals like fish, aquatic animals like fish, frog and all that. In what way anomalous expansion of water is advantageous to aquatic animals? This last short question. This is very important. Anomalous expansion. Answer. What is anomalous expansion of water? Anomalous means peculiar behavior of water. When pure water is heated from 0 degrees centigrade to 4 degrees centigrade, 0 degrees centigrade to 4 degrees centigrade. 4 degrees centigrade. This is very important. 4 degrees centigrade, 0 degrees centigrade. Water contracts. Generally, if you heat, it should expand. Generally, any solid or liquid, if you heat, it should expand. But from 0 to 4, water contracts. At 4 degrees centigrade, water has maximum density. At 4 degrees centigrade, water has maximum density and has minimum volume. Maximum density and has minimum volume. This is known as anomalous expansion of water. This is called anomalous expansion of water. What is anomalous expansion? This is the answer solution. When pure water is heated from 0 to 4, water contracts. At 4 degrees centigrade, water has maximum density and has minimum volume. This is called anomalous expansion of water. This is called anomalous expansion of water. Anomalous expansion of water. Where it is used? In cold countries. Not in our countries. In cold countries, what will happen now? Very cold season will be there. Cold countries, winter, lakes will be there. Lakes may be frozen because it goes to minus temperature. Then without water, how aquatic animals survive? How aquatic animals are surviving? That is the peculiarity. That is called application of anomalous expansion of water. That is called biological explication of anomalous expansion of water. I am going to explain next page. Application. You have draw the diagram. Application of anomalous expansion of water. I am drawing a diagram now. This is the pond here. The pond. So this is the minus. Lake is frozen. The lake is minus temperature. This water layers now. So below layers is always 4 degrees centigrade. 4 degrees centigrade water will be there. This is 3 degrees centigrade, 2 degrees centigrade, like 1 degree centigrade. Okay, students, eyes contact with this, like this. This is minus 10, lower contact of ice will be at 0 degrees centigrade, like this. 0 degrees centigrade, like this. So this is what happening But below layers, here fish can survive now. Fish can survive. So how do you explain this? How do you explain this? I'm telling you, in the winter season. So this is the diagram. This is the pond here. So this is the pond here. Lake. Pond is like this. In winter, in cold countries, lakes will be upper surface of lake is frozen. Upper surface of, because air in contact with that, upper surface of lake is frozen. So in winter, in cold countries, upper surface of lake is frozen. Okay, frozen. So when temperature goes below 4, so what will happen? When temperature increases from 0 to 4, water contract instead of expanding. Maximum density at 4. During winter, temperature of atmosphere falls below 0. The surface of lakes will be frozen. So lower surface of the ice, this is frozen -10, next 0. Frozen. But the lower layers of water remain at 4 degrees centigrade. As at 4 degrees centigrade, water has maximum density. And sinks to bottom. Even though upper surface is frozen at 4 degrees centigrade, water has maximum density and sinks to the bottom. So the cooling is not fast. As ice is a bad conductor. As ice is a bad conductor, and water is also a bad conductor. Therefore, complete lake cannot be frozen. In winter, cold countries, upper surface of lake is frozen because it is in touch with atmosphere. But lower surfaces of water remains at 4 degrees centigrade. Why it remains at 4 degrees centigrade? 4 degrees centigrade water has maximum density. So fish can survive easily. By the time the freezing thickness increases, by the time winter will be over, only part of the surface, only a small part of thing is only will be frozen, small thickness. Lower surface will remain at water. This is due to anomalous expansion of water at 4 degrees centigrade. Water has maximum density. Water cannot allow heating to the ice. Ice cannot allow cooling to the bottom. Because of this, it remains at 4 degrees centigrade at bottom, even though upper surface are frozen -10 and 0 and something like that. So the ice will float on surface of water, but remaining here, this is fish. Fish can survive under water. This is application of anomalous expansion of water. Now we are completed short questions, students. Now we are going to long questions. LAQs we are going now. LAQ, long questions. Long questions comes from the chapters work power energy, long questions comes from work power energy chapter. We are going to work power energy chapter. Long questions are coming from work power energy. State and prove law of conservation of energy in case of freely falling body. Long question first. So first chapter is what? Work our energy. There are 3 chapters in which long questions are coming. How many long questions are there? Work for energy 3, oscillations 2, thermodynamics 2. 7 long questions are there. Work for energy. What is the first question? Very, very important question is state and prove. State and prove. Law of conservation of energy. Law of conservation of mechanical energy. Conservation of energy in case of freely falling body. In case of freely falling body. Most important number of times is coming. This is most important question in work for energy. State and prove law of conservation of energy in case of freely falling body. Now I am drawing diagram. This is the ground point. A body is freely falling from the point A, which is at a height h from the ground. Which is at a point h from the ground. Point 8. So it reaches an intermediate point B here, final reaches the point C here. A to B distance traveled, assume x. Definitely remaining distance will be h minus x. So a body of mass m is freely falling. A body of mass m is freely falling. Freely falling means here u is equal to 0. Let us say at the point B, velocity is v1. At the point C, velocity is v. At initially velocity is 0. At the point B, velocity is v1. As body is coming down, what will happen? Height will decrease, velocity will increase. State and prove law of conservation of energy. Potential energy is mgh. Kinetic energy is half mv squared. Potential energy is law of conservation of mechanical energy. We want to prove that at every point A, B, C, we want to prove total energy remains constant. So we are writing now here a body of mass m is freely falling from the point A. You are seen from the point A. From the point A, which is at a height h from the ground. From the ground point C. From the ground point C. This is ground point C. A body of mass is m is freely falling from the point A, which is at a height h from the ground point C. So at A, naturally, we have potential energy. At A, potential energy. Potential energy I am writing U. What is potential energy? mgh. At A, potential energy U is mgh. What is kinetic energy? Kinetic energy. What is kinetic energy? K. That is 0. Because U is 0, kinetic energy is 0. U is 0. Half mu square. Therefore, U is 0. Kinetic energy will become what? 0 because U is 0. So total energy is what? Total energy I am giving by symbol E. Total energy is E. At A, potential energy plus kinetic energy. Potential energy is how much? mgh plus 0. Total energy will become answer how much? mgh. So total energy at A will become equal to what? mgh. I am again telling at A, potential energy U, mgh, kinetic energy K 0 because U is 0. Total energy at U plus K, potential energy plus kinetic energy, mgh plus 0, mgh. Again, after A, it is falling down. It is falling down. The body is falling down. It reaches at B. Before reaching B, it travels a distance x. So I am writing in next page. Please remember this diagram. It reaches B. It reaches B by traveling a distance x. By traveling a distance x from A to B. A to B. It reaches B by traveling a distance x from A to B. Let V1 is velocity at B. Let V1 is velocity at B. Therefore, what is height of B? I am telling. Height of B is not x. Height is always measured from ground. Height of B is nothing but h minus x. I showed you. Friends, you see, height of B. What is height of B? Height of B is nothing but h minus x. Height of B is from ground, you have to see BC, h minus x. So height of B is h minus x. Therefore, at B, potential energy mg into h minus x, or it is equal to mgh minus mgx, potential energy. Kinetic energy K. Kinetic energy is given by the formula half m v1 square. If I mix it, I could get mgh at B. This kinetic energy is this much. What I am doing now is from A to B. It is traveling from A to B. You take v square minus u square is 2as. It is falling down. v1 square minus u square. It is fallen through a distance x. U is 0. U is 0. v1 square is nothing but 2gx. What happens to u? U becomes 0. Initial velocity is 0. v1 square is 2gx. A to B, I am applying kinematics equation. Therefore, kinetic energy will become half m v1 square means 2gx. 2 gets cancelled. Kinetic energy I am going to get mgx. Therefore, at B, total energy at B, potential energy plus kinetic energy. What is potential energy? mgh minus mgx. What is kinetic energy? Plus mgx. This will get cancelled. Total energy at B will become how much? mgh. Total energy at B will become mgh. This is the proof. Energy at B. Energy at B. So energy at B. Potential energy mgh minus mgx. Kinetic energy half mv1 square. That will become mgx. Therefore, total energy will become mgh. Right. Finally, at C, if you take at C after reaching ground, what is at C? Let the body reaches C with a velocity v. Distance traveled A to C, S is equal to H. I'll show you. S is equal to H. A to C distance traveled is how much? H. Okay, students. Now, what is the height of C? Height of C is 0. It is reaching the ground. What is height of C? Height of C, it is on ground, is 0. Therefore, at C, potential energy, height of C is 0, mg into 0, potential energy is 0. Kinetic energy is given by the formula half mv square. It is reaching the ground with velocity v. But A to C, I am applying kinematics equation. A to C, if you take A to C, kinematics equation v square minus u square is equal to 2gh. u0, v square will become what? 2gh. Therefore, kinetic energy will become half mv square 2gh. 2 gets cancelled, it will become mgh. Total energy at C, I am finding total energy at C, potential energy plus kinetic energy. 0 plus mgh. So therefore energy at C is equal to mgh. We have got everywhere energy at A is equal to energy at B is energy at C is equal to mgh. Law of conservation of energy in case of freely falling body means what? At the point A, total energy mgh. At the point B also total energy is mgh. At point C also total energy is mgh. That is the proof. Proof of law of conservation of energy in case of freely falling body. So this is what they are asking in the long question. Along with some numerical they are giving student. Along with these 6 marks, generally they are asking a problem. The numerical they are asking. What is the numerical they are asking? I am reading out. If I cannot do also, a pump is required to lift 600 kg of water per minute from a well 25 meters deep and to eject it with a speed of 50 meters per second. A pump is required to lift 600 kg of water per minute from a well 25 meters deep and eject it with a speed of 50 meters per second. Calculate the power required to perform the above task. This problem 2 marks question they are giving. Power means what? Work by time. Power means what? Work by time. I am not writing on the board. Power is equal to work by time. Total problem is asked the students. So some power is there. Work by time. Work means you will write mgh. Pumping means half mv square by P. What is the power of the pump? They ask. To use this formula, you are going to get the answer. mgh, potential energy, kinetic energy half mv square by time. So this is the long question they are asking. Sometimes problem 2 marks, 6 marks theory. So next long question work for energy is, what is the long question? Describe the notions of work and energy. Develop the notions of work and kinetic energy. Work and kinetic energy. Develop the notions of work and kinetic energy and show that how it leads to work energy theorem and show how it leads to work energy theorem. Work energy theorem. Develop the notions of work and kinetic energy and show how it leads to work energy theorem. This is an important long question, 6 marks, along with some problem will be given. What is the notions of work and kinetic energy? We have to give work formula, kinetic energy formula we have to give. So here answer I am writing solution work. What is the notions of work? Work is said to be done by the force if it produces a displacement. Work is said to be done by the force if it produces a displacement and given by work is product of force and displacement. Given by work is nothing but Fs cos theta. Work is given by the formula Fs cos theta. What is F? Force. What is S? Displacement. Theta is the angle between F and S. You can write in dot product form also. F bar dot S bar. Work is scalar. SI unit is joule. This information you have to give. Notion work is said to be done by the force which produces displacement and given by W is equal to Fs cos theta. What is W? Work is given by the letter W. Work is said to be done by the force which produces displacement Fs cos theta. Theta is the angle between F and S. F bar dot S bar also you can write. Work is scalar product. Work is scalar. Okay, students, now I am telling about kinetic energy. Now I am telling about kinetic energy. అయిపోయింది ప్లేస్. ఇది వెళ్ళిపోయిందా? వర్క్ అండ్ ఎనర్జీ, నోషన్స్ ఆఫ్ వర్క్ అండ్ ఎనర్జీ ఉందా లేదా దాంట్లో? చూడండి, ఇప్పుడు నేను ఒక క్వశ్చన్ చెప్పాను, వర్క్ డెఫినేషన్ వచ్చిందా? ఎఫ్ఎస్ కాస్ట్ అయితే అక్కడ పోయిందా? ఉందా? వర్క్ ఉందిగా, డెఫినేషన్ ఉందిగా, ఉందిగా. ఓకే, రైట్. ఇది మళ్ళీ పేజ్ 52 వచ్చింది, పర్లేదా? ఉండనియా? లాస్ట్ ఇంకోటి వచ్చింది కానీ అది ఇక్కడ వచ్చింది కానీ అక్కడ రాలి. కైనటిక్ ఎనర్జీ స్టూడెంట్స్, కైనటిక్ ఎనర్జీ నోషన్స్ ఆఫ్ వాట్ ఈస్ కైనటిక్ ఎనర్జీ? ఎనర్జీ పొజిషన్ బై వర్చ్యూ ఆఫ్ మోషన్. ఎనర్జీ possessed by virtue of motion, is called kinetic energy. Wind in motion, bullet in motion, you have kinetic energy. Kinetic energy is given by the expression kinetic energy K is given by half mv square. Kinetic energy K is given by half mv square. Energy possessed by virtue of motion. Now I am deriving work energy theorem. What is work energy theorem? Statement. Work done by resultant force. What is work energy theorem? Work done by resultant force. Resultant force is equal to change in kinetic energy Work done by resultant force nothing but equal to change in kinetic energy. That is work energy theorem. What is work energy theorem? Work done by resultant force is equal to change in kinetic energy. So here there is a body here. You are applying the force F. It is applying the force F. It is having initial velocity U, obtains the final velocity V. In a time t seconds, it travels a distance S. Like this. A body is applied by the force, horizontal force F, initial velocity U. It is traveling with the initial velocity U. It is obtained final velocity V in a time t. Okay, students, I am doing derivation. In the next page. So, what is the basic formula for work done? Work done formula is Fs because theta is 0 degrees here. Okay, students. Then F is given by the formula MA. You know Newton's second law. So distance traveled, you can give distance traveled average velocity U plus V by 2 into T. What is distance traveled? Initial velocity plus final velocity by 2 into T. When it's moving with uniform acceleration. Substitute these two in the first equation. F is nothing but MA. S means U plus V by 2 into T. We'll write it. What is acceleration? Acceleration is given by V minus U by T. What is acceleration? V minus U by T. This is V plus U by 2 into T. T gets cancelled here. So work done, you are going to get M by 2 into V square minus U square. M by 2 into A minus B into A plus B. A square minus B square. This can be written as half MB square minus half MU square. Work done is nothing but given by half MB square minus half MU square. What is half mv square? Final kinetic energy. What is half mu square? Initial kinetic energy. So work done is equal to final kinetic energy minus. So what is final kinetic energy? Half mv square. What is initial kinetic energy? Half mu square. Half mu square. This is the answer. This is the answer. నితిన్ అది తీసేసేయండి, డిస్టర్బెన్స్ కావాలి, ఆ సౌండ్ తీసేసి మీరు పెట్టుకోండి. అది వద్దు, డిస్టర్బెన్స్ వస్తుంది. ఓకే. So these are the two important long questions. Under this also, they are asking some problem. Machine gun fires bullets. One problem they are asking. So in every standard book, you see some problem will be there. I am unable to do problem. First, I am completing this theory questions. So generally, luck is there, you won't get problem. But generally, they are giving one problem. That is 1 mark or 2 marks. They are giving problem. Remaining is theory. Major is theory only. Okay. Now, student, last question work for energy is, what are the types of collisions? That is a very important one. What are the types of collisions? What are collisions? What are collisions? What are collisions? What are collisions? Explain the possible types of collisions. Explain the possible types of collision. Explain the possible types of collision. Explain the possible types of collision. Develop the theory for one-dimensional elastic collision. Develop the theory for one-dimensional elastic collision. Elastic collision. First theory is there, 2 marks. What are the collisions? Explain the possible types of collision. That is one question. Develop the theory for one-dimensional elastic collision. Second part will come back. Develop the theory. First, what are the collisions? Collision. What is collisions? Answer. Collisions. We are telling about collisions. What is meant by collision? A physical interaction. Sometimes interaction, they may collide, they physically or not. Sometimes in collisions, sometimes atomic particles are gold nucleus, alpha particle scattering, that will come nearer to nucleus and scatter. That is also collision only. Generally, collisions, whatever we see collisions in life, they will be in contact only. So without contact also collisions possibility is there. A physical interaction between the bodies in which a large force acts for a short interval of time. Short interval of time. This is called impulses. Interval of a collision. What will happen? A large force acts for a short interval of time during collision. So what are the possible types of collisions? One is elastic collision. Second is perfect inelastic collision. These two I'll explain. Elastic collision and perfect inelastic collision. What is collision? A physical interaction between the bodies in which large force acts for a short interval of time. What are the collisions? One is elastic collision, another is perfect inelastic collision. Explain what is elastic collision, what are the points, what are the collisions, what are the important points. What is elastic collision? I'm writing elastic collision between perfectly elastic spheres like steel spheres, like that. Elastic collision. In elastic collision, what will happen? Total momentum is conserved. In elastic collision, total momentum is conserved. Conserved means remains constant. In any collision, total momentum is conserved. Total kinetic energy is also conserved. Total kinetic energy. KE means kinetic energy. KE means, you write in exam fully. Total kinetic energy. Total kinetic energy is also conserved. Conserved. Bodies will not undergo change in shape. Before collision, whatever shape is there, after collision also they will retain their shape. Of course, during collision the shape will change temporarily, but after collision they will retain their own shape. Bodies retain their shape. Bodies retain their shape. Retain the shape completely after collision. After collision, there is no loss of kinetic energy. So collision between two smooth steel balls. Example, collision between atomic particles. Collision between atomic particles like proton and neutron, like atomic particles. Atomic particles, perfect elastic collision. Then comes to inelastic collision, complete inelastic collision. This is elastic, total momentum is conserved, total kinetic energy also conserved, bodies retain their shape after collision. Collision between atomic particles, collision between two smooth glass spheres, billiard balls, collision between two smooth glass spheres, like that. What is inelastic, perfect inelastic collision? I am telling about perfect inelastic collision. Perfect or complete inelastic collision. Perfect inelastic collision. Perfect inelastic collision. In this first point, total momentum is always conserved. Total momentum is conserved. Total momentum is conserved. Conserved means total momentum before collision is equal to total momentum after collision. Total momentum is conserved. Conserved. Total momentum remains constant. But total kinetic energy is not conserved. Total kinetic energy is not conserved. Is not conserved. Means total kinetic energy before collision is not equal to total kinetic energy after collision. After collision, there is a loss of kinetic energy is there. In complete inelastic collision, there is a loss of kinetic energy is there. Bodies undergo change in their shape. Bodies undergo change in their shape. Change in their shape after collision. The exactly opposite to the elastic collision. Example, a bullet gets embedded in a block. A bullet gets embedded in a block hung by a thread. This is called hung by a thread. This is called ballistic pendulum. They move with common velocity. In case of perfect inelastic collision, they move with common velocity. This is the what are collisions, what are types of collision? Elastic collision, perfect inelastic collision. Now lastly is asking what? Develop the theory for one-dimensional elastic collision. One-dimensional elastic collision. One-dimensional elastic collision. What is one-dimensional elastic collision? One-dimensional elastic collision. One-dimensional elastic collision. We are discussing about one-dimensional elastic collision. One-dimensional elastic collision means what? Before and after collision, they move along a straight line. Before collision and after collision, they are moving along a straight line. That is called one-dimensional elastic collision. One-dimensional elastic collision means 1D One dimensional collision means before and after collision they move in a straight line. They move in a straight line. One day collision, before and after collision, bodies move in a straight line. That is called one-dimensional elastic collision. I am drawing a diagram now. There is a body, a small sphere M1, moving in a straight line U1, is hitting the second body M2, moving in same direction U2. I am thinking U1 is greater than U2. They are colliding for a short interval of time. These two bodies collide short interval of time. This is the force of interaction is there, internal forces. Due to this, after collision, body moves with a velocity v1, second body m2 moves with a velocity v2. This is diagram, one-dimensional elastic collision. m1 moving with a u1, m2 is moving with a u2. u1, u2 are collisions. u1, u2 are velocities before collision, initial velocities. m1, m2 are two spheres, small spheres of radius, very small radius. When they are colliding, there is interaction. This is internal force. According to Newton's third law, these are action-reaction forces. So after collision, they are moving with the velocities v1, v2. This is the diagram. Now I'll write equations. According to conservation of momentum, I'll write first. According to law of conservation of momentum, law of linear momentum. According to law of conservation of momentum, what is the formula? m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This is the first equation. According to conservation of momentum, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. m1 v1 initial momentum of first body, m2 u2 initial momentum of second body. m1 v1 initial momentum of the final momentum of the first body, m2 v2 final momentum of second body. Okay, students, this is conservation of momentum. You can bring m1 terms this side, but it will go up, I think. But I'll write next. So I'm writing this step. m1 into u1 minus v1. I'm bringing m1 terms. m2 into v2 minus u2. This is the second equation. m1 u1 plus m2 u2 plus m1 v1 plus m2 v2. I'm taking m1 into u1 minus v1 is equal to m2 into v2 minus u2. That is second equation. Law of conservation of kinetic energy, because elastic. It is elastic. Law of conservation of kinetic energy is valid. Law of conservation of kinetic energy. What is that? Half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. I am bringing m1 terms this side. Half m1, this is equation number 3. Equation number 3, half m1 u1 square minus v1 square. I am bringing m1 terms this side. Is equal to half m2 terms left side. v2 square minus u2 square. Half m v2 square, half m2 u2 square. In this half gets cancelled. I am getting this equation. m1 into u1 square minus v1 square is equal to m2 into v2 square minus u2 square. This is the fourth equation. I am taking second equation, fourth equation. All of you see second equation and fourth equation. 4 divided by 2. 4 divided by 2. I am doing all these mathematics for getting the answer. 4 divided by 2. 4 divided by 2. What is 4? m1 into v1 square minus u1 square divided by 2. m1 into v1 minus u1. 1 minute. here, sorry. So here m1 into u1 square minus v1 square by m1 into u1 minus v1 is equal to m2 into v2 square minus u2 square by m2 into v2 minus u2. m1 gets cancelled, m2 gets cancelled. A square minus b square, u1 plus v1 into u1 minus v1, I will write a plus b into a minus b, by u1 minus v1 is nothing but equal to v2 plus u2 into v2 minus u2 by v2. This is a little bit mathematical square. Carefully you have to practice, other will do wrong. Practical, you do very slowly. You will get u1 plus v1 is nothing but v2 plus u2. You will get reading like this. u1 plus v. That means it implies that u1 minus u2 is equal to v2 minus v1. Change in velocity before collision equal to change in velocity after collision. u1 minus u2, change in velocity before collision. v2 minus v1, change in velocity after collision. So this is the equation. u1 plus v1 plus equal to v2 plus u2 I am getting. This is the equation number 5 if you take. This is the equation number 5. This is the equation number 5. What is equation number 5? u1 plus v1 is equal to u2 plus v2. u1 plus v1 is equal to u2 plus v2. Remember this equation? From this we have derived v1 and v2. From this we have derived v1 and v2. Now I am writing once again u1 plus v1 is equal to u2 plus v2. u1 plus v1 is equal to u2 plus v2. I am eliminate equation number 3. I am eliminating v2 here. u1 plus v1 minus u2. u1 plus v1 is equal to u2 plus v2. v2 is equal to u1 plus v1 minus u2. This is important equation for v2, eliminating v2. Okay. This is the equation number something, equation number 6. Substitute the sixth equation. So what I am trying to do is to derive expression for v1. To derive expression for v1. What is v1? Velocity of the first body after collision. To derive the expression for v1. v1 is what? Velocity of the first body after collision. So v1 I want to do it, substitute 6. Substitute 6 in second equation. What is second equation? m1 into, I am writing u1 minus v1, that will be there like that. m2 into v2 minus u2. v2 minus u2 means v2 is this one. u1 plus v1 minus u2 minus u2. m is equal to v2 minus u2. I am eliminating v2. What is v2? u1 plus v1 minus u2 minus u2. I am taking m1 u1 minus m1 v1, m2 u1 plus m2 v1 minus m2 u2 minus m2 u2 minus 2 m2 u2 I get. Minus m2 u2 minus m2 u2. 2 u2s are there. Minus m2 u2 minus m2 u2. 2 m2 u2 you are going to get. I am bringing u1 terms one side. u1 terms one side means m1 u1 minus m2 u1. One term I will get it. Plus 2 m2 u2. I will bring this side. Plus 2 m2 u2 it will become m1 v1 plus m2 v2. m1 v1 plus m2 v2. If you arrange the terms, you can easily understand. m1 u1 minus m2 u1 is equal to plus 2 m2 u2 is equal to m1 v1 plus m2 v2. So I am seeing in next page now. If you take u1 common, I will get like this: m1 minus m2 into u1 by m1 plus m2 plus 2m2 by m1 plus m2. Sorry, u1 plus 2m2 u2 is nothing but v1 into m1 plus m2 will get v1 into m1 plus m2. If you see the previous step, so it implies that final velocity v1 will become, you divide by m1 plus m2, m1 minus m2 by m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2 will get. This is the expression for v1. This is the expression for V1. You have practiced a lot. It will have small confusion will be there for the general. I see the students, they'll confuse a bit. So in the online class also I am trying very legibly to explain this question very neatly to you. I got V1 student expression M1 minus M2 by M1 plus M2 into U1 plus 2M2 by M1 plus M2 into U2. Similarly, I want to derive expression for V2, to derive expression for V2. Generally, students will ask whether to derive both. If you write 99% you get marks. Somebody expect V2 derivation also. To derive the expression for V2, what you have to do is, again, you take the expression, fifth expression, U1 plus V1 is equal to U2 plus V2 is there. Na? From that, you eliminate V1 now. What is eliminate V1? V2 plus U2 minus U1 you get. To derive the expression for V2, what I am doing, U1 plus V1 equal to U2 plus V2. So what is V1? So what is V1? V1 is equal to V2 plus U2 minus U1. Substitute this in the first equation, in the second equation. M1 into U1 minus V1. Minus V1 means V1 is nothing but V2 plus U2 minus U1. M1 into U1 minus V1 is equal to M2 into V2 minus U2. From this, V2 should be calculated. So it will go up a little bit up, I think. It's no problem for you. From this onwards, you count M1 U1. Okay, students, minus V2. So I'm keeping brackets once again. Minus V2 minus U2 plus U1. M1 U1 minus V2 minus U2 plus U1. That is nothing but equal to M2 V2 minus M2 U2. Here U1 plus U1, 2 U1. 2 M1 U1 you will get, minus M1 V2 I will get, minus M1 U2 also I will get it. Here I will get M2 V2 minus M2 U2, minus M2 U2. Okay, I am bringing 2 M1 U1, I am keeping like that one only. I am bringing U2 term this side. Then what will happen? Plus M2 U2 minus M1 U2 will be there. Then M2 V2 plus M1 V2 will be there. So it will come as 2 M1 U1 plus U2 into M2 minus M1 you will get. It will become V2 into M2 plus M1 or M1 plus M2 you will get. Finally answer what you are going to get. Sorry, this is V2. V2 into M1 plus M2. So it implies that V2 is nothing but 2M1 divided by M1 plus M2, 2M1 by M1 plus M2 into U1 plus M2 minus M1 by M1 plus M2 into U2. This is the notions of final velocity, V2 and V1 expressions in case of one-dimensional elastic collision. This is only a little bit big. There are 3 long questions are there. One will come. One is law of conservation of energy in case of freely falling body. That is more the times that is asking 60%. Then 35% they are asking collisions. 15-20% they are asking work energy theorem. This is the order they are asking. This is the long questions under work energy power. Friends, now we are going to oscillations chapter. In this one, long question is coming. Oscillations. The chapter oscillations chapter. We are going to do the oscillations chapter. In oscillations chapter, next long question is coming. Oscillations chapter. Define simple harmonic motion. Show that motion of simple pendulum is simple harmonic. Hence, derive the expression for time period. What is seconds pendulum? So, students, I am explaining, I am writing. Show that oscillations first question. Show that motion of simple pendulum is simple harmonic. Show that motion of simple pendulum is simple harmonic. Motion of simple pendulum is simple pendulum is simple harmonic. Show that motion of simple pendulum is simple harmonic. And hence derive the expression for time period. And hence derive the expression for its time period. What is seconds pendulum? What is seconds pendulum? Show that motion of simple pendulum is simple harmonic, and hence students, you have to answer everything. You have to prove that simple pendulum motion is simple harmonic, you have to prove, and the time period derivation you have to do, and seconds pendulum definition you have to write. There is no problem they are giving. This is the safest question in which problem is not given. So what is simple pendulum? You have to draw a diagram, student. First I am drawing a diagram. Simple pendulum. There is a splitted cork will be there. The thread here. There is a bob here. Just heavy point mass. Okay, students. This is called point of suspension. It's called length of the pendulum. So what is simple pendulum? This is a cotton thread. So this is a point mass of mass m here. What is simple pendulum? What is simple pendulum? Definition we are giving. So simple pendulum, what is meant by simple pendulum? Simple pendulum. How it is made? Simple pendulum, I am taking this point as O, this A. Simple pendulum, very simple apparatus. Simple pendulum is a heavy point mass or bob, point mass, heavy point mass, small bob of mass m, attached at one end of the light massless, light inextensible string, massless, by fixing other end at O. Other end at O. Simple pendulum is a heavy point mass attached at one end of the light inextensible string by fixing other end at O. O is called point of suspension. L is called length, OA, that is called point of suspension. OA is called length of the pendulum. L. It is under gravity actually. So simple pendulum is a heavy point mass attached at one end of the light inextensible string inextensible. It is not elastic. By fixing other end at O, O is called point of suspension. O is called O to A is called L, length of the pendulum. So I am doing derivation part to you. To derive the expression for time period, you are drawing once again simple diagram. I am drawing simple diagram. This is point O. I am drawing simple diagram. I am pulling by small angle theta. I want small angle theta here. Small angle theta I am pulling now. This is O. This is A. This is B. This is displacement X here. Now, here what will happen? At B, tension, this is called tension. Here you are different very clearly. This is weight is acting downwards like this. So this is nothing but this is theta. This is also theta. This is called mg cos theta balanced by tension. Another component will be there. Mg sin theta. Mg cos theta. This should be very clear. Mg cos theta. Mg cos theta. To derive the expression for time period. To derive the expression for time period. In this only we will get oscillations are simple harmonic. Expression for time period. Time period means time taken to complete one oscillation. Time period T. To derive the expression for time period. So what we are doing is pendulum is there. Pendulum is there. This straight only, unable to draw actually this straight. Right? So at B, tension is balanced. It is a tension. At B, tension that is T dash, tension T dash is equal to mg cos theta. Weight is resolved into components. Weight of Bob at B is resolved into components. Into components. So A to B displacement is what? X. This is B point. So let AB is displacement X. Let AB is displacement X. Restoring force opposite the displacement. So restoring force F is given by mg sin theta minus restoring force. Force and displacement are opposite. This equation is not very important, but this equation is important. Restoring force is nothing but minus mg sin theta. This is called restoring force. A is called mean position, B is called other position, other than mean position. Bob always tries to mean position. When you pull by displacement X, A to B tries to come to A. Restoring force minus mg sin theta. Theta is for very small. You can take for small angles. Sin theta is equal to theta. For small angle, sin theta is equal to theta. Therefore, F will become minus mg theta. Force will become minus mg theta. Force is becoming minus mg theta. Okay, students, I am writing in the next page. Force, you are writing. What is force? Minus mg theta. From diagram, you know F is equal to ma. We know F is equal to ma. So ma is nothing but minus mg theta. Mm gets cancelled. A will become equal to minus g theta. A will become equal to minus g theta. From diagram, I am bringing down this diagram. Diagram theta is equal to x by L. From diagram, theta is equal to x by L. This is L. For small angle, this is also L. Here tension is balanced by weight. Here tension is balanced by weight here. Tension is balanced by mg cos theta here. Okay, students, I am showing you theta is nothing but x by L, arc length by radius. Theta is equal to x by L. Theta is equal to x by L. Theta is equal from diagram. Theta is equal to x by L. Theta is equal to x by L. L equal to length of the pendulum. Therefore, acceleration is equal to minus gx by L. G and L are constants. Hence, G and L are constants. Acceleration is proportional to minus x because G comma length constants. G comma L constants. Therefore, oscillations of simple one. Therefore, it implies that oscillations of simple pendulum is simple harmonic. Oscillations of simple pendulum is simple harmonic. What is simple harmonic condition? It should be oscillatory. What is simple harmonic condition? It should be oscillatory motion, but acceleration should be proportional to the displacement. Acceleration A is called acceleration, X is called displacement. Acceleration should be proportional to displacement, but in opposite direction. That is the definition of SHM. Definition of SHM is what? Simple harmonic motion is an oscillatory motion where the acceleration is directed to the mean position. Acceleration is proportional to the displacement, but in opposite direction. That condition is received here. After getting this answer for SHM, we know for SHM, SHM means for simple harmonic motion, A is equal to minus omega square x. We will compare this. This is Roman letter 1, this is Roman letter 2. From 1 and 2, from 1 and 2, what you will get? What is 1 and 2? From Roman letter 1 and 2, again I am writing. From Roman letter 1 and 2, what you are going to get? From 1 and 2, A is equal to minus omega square x. A is equal to minus g by L into x. Compare, omega square will become g by L. Omega square, compare, omega square will become omega angular velocity. Omega is under root g by L. Omega is under root g by L. G by L. What is time period? Time period in rotatory motion or oscillatory motion. Time period is given by 2 pi by omega. Time period is given by 2 pi by omega. Omega is angular velocity. Hence, we get time period is 2 pi under root g by L. So, time period you are going to get 2 pi square root L by g. This is time period expression. While derivation expression, time period is 2 pi square root L by g, in which mass of the bob is not there. It depends on length of the pendulum and depends on acceleration due to gravity. Time period of simple pendulum depends on length of the pendulum and acceleration due to gravity. Lastly, second pendulum definition is there. What is second pendulum? Up to this you are getting 6-7 marks. What is second pendulum? What is second pendulum? The pendulum whose time period is the pendulum whose time period is t 2 seconds. Time period is 2 seconds. The pendulum whose time period is 2 seconds is called second pendulum. Is called second pendulum on the earth. Second pendulum. So, generally length of second pendulum on earth, if you calculate length of seconds, this is you need not write actually, this is enough. Length of second pendulum on earth, L is equal to 1 meter on earth. L is equal to 1 meter 100 centimeters. This is the long question, first long question oscillations. First long question oscillations. Nitin? ఇంకా 3 లాంగ్ క్వశ్చన్స్ అవుతాయా? 3 ఉన్నాయి. ఒకటేమో 449 అయింది ఇప్పుడు. ఈ చాప్టర్లో ఇంకోటి ఉంది, ప్రొజెక్షన్ అది అయిపోతుందేమో 5-5కి. ఇంకో చాప్టర్ 449 అయింది ఇప్పుడు. ఇంకోటి అయిపోతుంది. అది కాకుండా ఇంకా 2 మిగులుతాయి థర్మోడైనమిక్స్లో 2 మరి సార్ చెప్పాలి ఇవి కూడా అన్ని కంప్లీట్ చేయమన్నాడు అనుకో చేయలేకపోయింది. ఆ?
5:30 వరకు కంప్లీట్ చేసినాను.
ఉంటారా మీరు ఉంటారా మరి అన్ని కంప్లీట్ అయినా లాంగ్ క్వశ్చన్
5:30 వరకు అయిపోతుందా?
5:30 అయిపోతుంది. ఓకేనా? మళ్ళీ ఆ రోజున మరి ఫ్రెష్గా స్టార్ట్ చేస్తే బెస్ట్. మండే నాడు సెకండ్ ఇయర్ స్టార్ట్ చేస్తే బెస్ట్. మళ్ళీ ఉండిపోతే మళ్ళీ కష్టం. ఓకేనా? Friends, next one more question is there. In oscillations, show that projection of uniform circular motion on any diameter is simple harmonic. This is also they are asking very much. Show that projection of uniform circular motion on any diameter is simple harmonic. That is another long question. In oscillations. Another long question is show that projection of uniform circular motion on any diameter is SHM. For this, is asking definition also. Show that projection is telling define simple harmonic motion. One more thing is given. Define simple harmonic motion. So I am writing this part here. Friends, I am writing in this. One more thing is there. So here define simple harmonic motion. Define simple harmonic motion. Show that projection of uniform circular motion and diameter is such. What is definition? Simple harmonic motion. What is simple harmonic motion? Simple harmonic motion. SHM. This is short form is called simple. A to and fro motion. To and means oscillate. A to and fro motion of a particle. A to and fro motion of a particle for which acceleration is always proportional to displacement and directed to the mean position. Mean position or equilibrium position. What is the definition? To and fro motion of a particle along a straight line for which acceleration is always proportional to displacement directed to the, this is the mean position. So displacement is this side, acceleration is this side. Acceleration is always directed to the mean position. This is called mean position. Or equilibrium position. So what is the definition? We are telling, this is the diagram. Acceleration is always proportional to x or y. X displacement means x, or y displacement means y. X displacement means x. Acceleration is x. X is also displacement. Y is also. This is x displacement. X is directed to the right side. Acceleration is directed to the left side, but proportional to displacement. X is more, acceleration is more. X is less, acceleration is less. X is more, acceleration is more. X is less, acceleration is less. X is 0, acceleration is 0. But acceleration and displacement are in opposite direction. A to and fro motion of a particle, oscillatory motion. Pendulum clock moves from mean position to extreme, come to mean, again goes to extreme, come to mean. It will oscillate like this. This is called oscillatory motion. It is a periodic motion. The definition of simple harmonic motion. position. Different direct mean position is called SHM. Is called SHM, simple harmonic motion. This is called simple harmonic motion, oscillatory motion. It is a periodic motion. It is simple harmonic motion. It is a periodic motion. Time period is constant. Periodic motion. This is the definition of simple harmonic motion. I am now now keeping diagram. I am keeping diagram, students. Circle. This is the circle. Drawing a diagram. This is center. O. This is center. I am drawing y-axis also. Y-axis also. This is x-axis. This is y-axis. This is y-axis. Y-axis. Okay. Now O. Take the particle somewhere here. This is making rotatory motion. This describes an angle theta, let us say. You drop, what is projection means? You are dropping a perpendicular. You are dropping a perpendicular n. You are dropping a perpendicular m here. So this is, what is P? P is moving like this. So let P is exhibiting circular motion. Let P is exhibiting circular motion. Let P is exhibiting, P is particle exhibiting circular motion. Its foot of the perpendicular. So, sorry. Yeah. Its foot of the perpendicular. Draw perpendicular properly. Draw perpendicular properly. This is N. This is M. But this is theta. This is also theta. Phase of P. What is phase? Phase of P is nothing but theta. Theta is given by omega t. Phase of P is theta. That is nothing but omega t. OM. What is OM displacement? Y. OM displacement is X. Okay, students? Okay, students? OP is nothing but, this is theta, this is also theta. Okay, OP is nothing but what? OP or OM, OP is nothing but what? Radius. OP is nothing but what? Radius, or they will say amplitude A also. Amplitude means maximum displacement. Radius or amplitude A, amplitude A. Okay. Now phase of P, phase means angle, phase of 3, theta equal omega t. T is time. Omega angular velocity. Omega means angular velocity. Now we are writing, actually P is making circular motion means M is foot of the perpendicular. M is projection point. M is projection point on y-axis. As P completes one rotation along circle, P completes one oscillation along diameter Y. This is y dash. M is projection. M oscillates along y-axis. M oscillates along y-axis diameter. M oscillates along y-axis diameter. As P completes circular motion, M completes one oscillation. So you see the figure, triangle. I am taking triangle OMT, triangle OPM. What is triangle OPM? If you take triangle OPM, sin theta, I am writing sin theta is nothing but OM by OP. Okay, I am writing in the next Sin theta is nothing but OM by OP. OM by OP. OM means what? Displacement. Sin theta is nothing but Y by R. Or sometimes R will given as A also. So Y is equal to R sin theta. This is displacement equation. You start from mean position. Y is equal to R sin theta. Or you can write Y is equal to A sin theta. Y is equal to A sin theta. Theta is omega t. Theta is omega t. A sin omega t. A sin displacement equation is A sin omega t. Displacement equation is A sin omega t. Because R is nothing but equal to amplitude A. This is equation number 1. I am differentiating and finding out velocity. Velocity is nothing but dy by dt. I am finding velocity of the dy by dt. If you differentiate this one, A sin function, you are going to get cos omega t into omega t differentiation omega. Therefore, velocity will get omega A cos omega t. Omega A cos omega t. Velocity expression. Again, acceleration I want to prove. Acceleration is again rate of change of velocity. Omega A constant. What is cos omega t differentiation? Minus sin omega t. Cos minus sin omega t into omega t differentiation is omega. Omega A cos omega t. Omega A cos omega t differentiation sin omega t into omega. Therefore, acceleration will get minus omega square A sin omega t. But what is A sin omega t? What is A sin omega t from equation 1? It is nothing but y. This is equation 2. This is equation 3. But from equation 1, A sin omega t is 1. Therefore, A is nothing but minus omega square y. A is nothing but minus omega square y. It proves that acceleration is proportional to minus y. Omega is constant. Omega is constant. We have to prove that A is proportional to minus omega square. A is proportional. Therefore, projection is SHM. Projection makes SHM. Projection M makes SHM, simple harmonic motion. Because this condition is satisfied. A is proportional to minus y is satisfied. This is called projection of uniform circular motion and A diameter is SHM. This is second long question from oscillatory motion. Now, final chapter I am doing now. Final long question, thermodynamics. I am doing thermodynamics. Final long question comes from completely different chapter. Work for energy mechanics chapter, oscillations mechanics chapter, in which we have some expressions like velocity, acceleration, everything. Thermodynamics is a branch dealing with mechanical energy and thermal energy. Mechanical energy and heat energy. Conversion of mechanical energy to heat energy to mechanical energy will be there. What is first question, thermodynamics? State Kelvin Planck statement of state second law of thermodynamics. 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 How is heat engine different from refrigerator? How is heat engine different from refrigerator? Different from refrigerator. State second law of thermodynamics. How heat engine is different from refrigerator. I am telling about second law statements. Second law of thermodynamics. You know first law. First law is dq equal to dq plus dw. What is second law? Relates heat engine and refrigerator. Working of heat engine and refrigerator is not explained by first law of thermodynamics. It is explained by second law of thermodynamics. Second law of thermodynamics, there are two. Second law of thermodynamics. Second law of thermodynamics. That is, first one is Kelvin Planck statement. Kelvin Planck statement. Kelvin Planck statement. What is Kelvin Planck statement? So you cannot completely convert heat. It is impossible to convert complete heat energy to work. It is impossible to convert complete heat energy to work. Heat energy to work. Ideal heat engine or ideal heat engine with 100% efficiency is not possible. With 100% efficiency is not possible. It's not possible. What is second of thermal is? It is impossible. It is impossible to convert complete heat energy to work without rejecting some of the heat to sink. Ideal heat engine with 100% efficiency is not possible. Both are one and the same. It is called Kelvin-Planck statement. I'll tell Clausius statement. Second one is Clausius statement. Clausius statement. What is Clausius statement? Heat cannot. Second Clausius statement. Heat cannot flow from cold body to hot body. From cold body to hot body. Heat cannot flow from cold body to hot body without external agency. Without external agency. It is impossible to construct ideal refrigerator. It is impossible, or it is any statement you can write. It is impossible to construct ideal refrigerator. You know, refrigerator at home you are seeing what refrigerator is done. In refrigerator, it is impossible to construct ideal refrigerator. So what will happen? If you are keeping items, it become cooler and cooler. To save the food items also you are keeping. This is called Clausius statement. This will carry 2 marks, student. Now I am telling what is the difference between heat engine and refrigerator. What is the difference between heat engine and refrigerator? I am writing heat engine first. What is heat engine device? Heat engine consists of what parts? Heat engine consists of parts. What is the parts you are having? Hot reservoir source is always at higher temperature. There is an engine. Work is done by the engine. Here, there is a sink here, cold reservoir. This diagram, sink. It is at temperature T2. Here work. This is engine. This is the parts. What are the parts here? Source. What are the parts? What are the parts of heat engine? Source is at higher temperature. Heat is drawn from this. Heat is drawn here, Q1. Heat is rejected to here, Q2 here. Work done is nothing but Q1 minus Q2. Source is at higher temperature. Hot reservoir. Source is at higher temperature. T1. Right. Then sink. Sink is at lower temperature. Sink means atmosphere. Sink is at lower temperature. Sink is at lower temperature. Sink is at lower temperature T2. Third, let Q1 is the heat drawn from the source. Let Q1 is heat drawn from the source. Let Q2 is heat rejected to sink. Heat rejected to sink. So work is done by the engine. In this process, work is done by the engine. Work is done by the engine. Work is done by the engine. It goes down, don't worry. So work diagram already there. Source is at higher temperature, sink is at lower temperature. Let Q1 is the heat drawn from the source. Let Q is heat rejected to sink. W is work done by the engine. Work done by the engine. So efficiency, I'm giving you efficiency now. Efficiency eta is given by work done by Q1, heat drawn. What is Q1? Heat drawn from source, efficiency. What is the formula? Efficiency you are going to get. W is nothing but Q1 minus Q2 by Q1. Efficiency is given by 1 minus Q2 by Q1. Efficiency from heat engine is given by the 1 minus Q2 by Q1. This is the formula for heat engine. This is the heat engine. Source is at always higher temperature, sink is at lower temperature. Work is done by the engine. Q1 is heat drawn from source. Let us 100 joules is drawn, 70 joules is 30 joules is rejected to sink. Remaining 70 joules is work done. Like that. So I am doing now refrigerator. What is refrigerator? I am drawing refrigerator diagram. Differences also you can write. Separately you can write in tablet. What is refrigerator? This is 8 marks question. Heating and refrigerator. I am drawing once again. This is a source at higher temperature always. Then this is a engine. Work is done on the engine. This is sink again. Sink is at lower temperature T2. Heat is drawn from this. Heat is rejected to this. Reverse now. Q1. So first source is always at higher temperature. Source is at higher temperature. T1. Hot reservoir. Sink is at, there is common points. Sink is at lower temperature. T2 Kelvin. Then heat is drawn from sink. Sink and rejected to source. It is drawn from sink and some part of heat rejected to source. Q2 is heat drawn from this. You are seeing diagram here. This is Q2. Is heat drawn from source. Q1 is heat rejected to sink. We reverse here. Work is done on the system. This is important. Work is done on the engine system. So here I am drawing. Work is done. We have right. Work is done on the engine. Next page I am writing work done is always given by the formula Q1 minus Q2. Coefficient of performance will come. This is a different factor called coefficient of performance. Coefficient of performance of refrigerator. That is given by the letter alpha or beta. Coefficient of performance by refrigerator alpha. Alpha is given by the formula Q2 by W. Alpha is greater than 1. Alpha coefficient of performance greater than 1. I'll go to before point. Heat engine. So here eta is less than 1. Efficiency is always less than 1. Coefficient of performance is greater than 1. So this is regarding, this is very, very easy question. Distinguish what is second law of thermodynamics, 2 marks will be there. Heat engine 4 points, refrigerator 4 points, you are right, that is 4 you are having. So you are right, entire things with diagrams, you are going to get generally 8 marks. This is easy question. Last question from thermodynamics is, 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 what are reversible and irreversible processes? What are reversible and irreversible processes? What are reversible and irreversible processes? The Carnot engine, reversible process. Describe the working of Carnot engine. Describe the, this is also very important. Describe the working of Carnot engine. Describe the working of Carnot engine, and obtain the expression for efficiency, and obtain the expression for its efficiency, efficiency. What are reversible and irreversible processes? Describe the working of Carnot engine and obtain the expression for Carnot engine is the ideal heat engine in which you will get more than 90% or 95% efficiency. Carnot engine is a cyclic process actually. What are reversible and irreversible process? First I am writing definition. What is reversible process? Reversible, for this 1 mark will be there. Reversible process, I am telling ice to water, water to ice. It is, oh, just 10 minutes, 10 minutes please. What are reversible and irreversible process? A process that can be retraced back. A process that can be retraced back. A process that can be retraced back in same direction. A process that can be retraced back in same direction is called reversible process. Is called reversible process. A process that can be retraced back in same direction is called reversible process. Example, melting of ice. Example, melting of ice. Vaporization of water. Vaporization of water. Water becomes vapor. Vapor condenses back to water again. Ice melts to water. Water defreezes to ice here. Melting of ice. Ice to water, water to ice possible. Water boiling, becoming steam, steam to water is possible. So this is reversible process. What is irreversible process? Nature, most of the processes are irreversible. Irreversible process. Generally in nature, processes are reversible. Processes are irreversible. Generally in nature, processes are irreversible because a process that cannot take place in same steps, a process cannot retrace back, a process that cannot retrace back, a process that cannot retrace back is called irreversible. Work done against friction. Example, work done against friction. What is the meaning that? For example, you are doing work against friction, heat is generated. With the help of heat, again you cannot run the vehicle. For example, vehicle is running. With the help of brakes, you are stopping the vehicle. When you stop the vehicle, between tires and road, friction will be there. Due to friction, it will get stopped. Heat energy generated. But again, heat energy cannot run the vehicle again, cannot be complete converted to kinetic energy again. So in nature, most of the processes are irreversible. Work done against friction is irreversible. This is called reversible and irreversible process. Reversible and irreversible processes. So most of the processes in nature are irreversible. They cannot retrace back. Now I am telling about Carnot engine. Lastly, I am telling you about Carnot engine. Carnot engine. Carnot is a scientist. Carnot engine. It is a cyclic process. It is a cyclic process. It is a cyclic process. Cyclic process. Cyclic means I am drawing diagram and showing Carnot engine is a cyclic process. Carnot engine, I am drawing, students, PV diagram, pressure versus volume. I am drawing pressure versus volume, P versus V. V means volume, P means pressure. I am showing the graph now. The cyclic process starting from point A, isothermal expansion, adiabatic expansion, isothermal compression, adiabatic compression, like this. See, student, I am drawing here isothermal compression. Isothermal, I am starting from initial pressure here, P1, V1, T1. Here isothermal process, pressure will change, P2, V2, T1. Temperature will remain same. P1, V1, T1, P2, V2, T1. This is adiabatic. So this is adiabatic. Now here pressure P3, here V3, T2 here, P3, V3, T2. Here it will become P4, V4, T2. This is isothermal once again. Finally P4, V4, T2 to P1, V1, T2. This is called cyclic. Wherever it is starting, is coming back to same point. Okay, students, I am writing A, B, this is C, this is D. I am writing here, what is AB? Isothermal expansion. Isothermal means temperature should remain constant. So what is AB? Isothermal expansion. AB is called isothermal expansion. BC is called adiabatic expansion. BC is called adiabatic expansion. BC is called adiabatic expansion. Okay, students. CD is called isothermal compression. CP is called isothermal compression. Compression means volume is decreasing. Isothermal compression. D2A. I'll show you once again figure. D2A. Student, adiabatic compression. D2A is called adiabatic compression. Adiabatic compression. AB is called isothermal expansion. BC is called adiabatic expansion. CD is called isothermal compression. DA is called adiabatic. This is cyclic process. I am showing this diagram once again to you. Friends, please see this diagram. Please, I am hold here. Please see here. AB is called isothermal expansion. Volume is increasing V1 to V2. Temperature remaining same. B to C, adiabatic expansion. Volume is decreasing. Sorry, volume is increasing. Adiabatic expansion. Temperature is also changing T1 to T2. Isothermal compression. Volume is decreasing. Isothermal compression. Temperature is remaining same. Adiabatic compression. Temperature is changing. So it is coming to again initial temperature. What is initial temperature? T1. So again it is coming to initial temperature. It is starting from T1, coming to same initial temperature. Therefore, cyclic process change in internal energy is 0. Now, I think you have idea. P is called pressure, V is called value. This is called the graph, PV diagram graph. Then one by one I am explaining, I am deriving expression for efficiency. Deriving expression for efficiency. Deriving expression for efficiency. So what is AB, Nana? Please you see the diagram back. What is AB? Isothermal expansion. In isothermal, now you see the derivation very carefully. Isothermal expansion, AB. Isothermal means temperature should remain same. I am showing what is isothermal expansion. P1, V1, T1, 2, P2, V2, T1, right? P2, V2, T1. In this process, heat is absorbed. What is heat absorbed? Equations I am writing. Q1 is heat absorbed. Q1 is heat absorbed. This is called heat absorbed. Heat absorbed. Q1 work done is also same. Q1 is equal to W1 work done. What is work done formula? nRT1. This is the formula ln final volume by initial volume. So P1 T1 to P2 V2 T2. V2 is greater than V1. V2 is greater than V1. nRT1 ln V2 by V1. Heat energy is also nRT1 ln V2 by V1 only. Work done is also nRT1 ln V2 by V1 only. This is isothermal expansion. Then BC is called adiabatic expansion. BC is called what? Adiabatic expansion. Isothermal expansion temperature is constant. But adiabatic expansion, what is adiabatic expansion? P2 V2 T1 to P3 V3 T2. P3 V3 T2. P2 V2 T1 to P3 V3 T2. Here in adiabatic expansion heat energy is 0. In adiabatic expansion heat energy is 0. Work done W2 is nothing but nR by gamma minus 1. N is the number of moles. nR by gamma minus 1. Adiabatic expansion temperature falls. T1 minus T2. This is second equation. This is first equation. This is second equation. So in isothermal expansion, heat energy is equal to W1 nR T1 ln V2 by V1. What about heat energy here? Adiabatic heat energy is 0 because change in heat energy is 0 in adiabatic. Adiabatic process, there is no absorption or release of heat. So this is adiabatic expansion. I am telling you about CD. So this is first and second. You remember adiabatic expansion. I will tell you next page. Next page. AB, BC is what? CD. CD. Isothermal compression. Isothermal compression means you can see diagram. If you get doubts, I'll show you diagram. Isothermal compression means what? P3 V3 T2 to P4 V4 T2. P3 V3 T2 to P4 V4 T2. This is called, CD is called isothermal compression. CD is called isothermal compression. So isothermal compression, P3 V3 T2 to P4 V4 T2. So what is work done here? W3 nR T2 ln V4 is less P3. Final volume negative will get. You will get negative work here. This is called negative work. I will get negative work, students, and minus nR T2 ln initial by final you keep. Final by initial if you keep, negative you get. So W logarithm. So W3 minus nR T2 ln V3 by V4. Finally, dA. What is dA? Adiabatic expansion. What is adiabatic? Adiabatic compression. Final dA is called adiabatic compression. Adiabatic compression. What is adiabatic compression? From what to what? P4 V4 T2 to finally P1 V1 T1. dA, adiabatic expression. So W4, I am writing W4. Again, this is negative again. This is again negative. This is negative. Compression means negative. nR by gamma minus 1 into T1 minus T2. Because here initial temperature is T2, final temperature is T1. Initial temperature T2, final temperature T1 means T1 is greater than T2. So minus nR by gamma minus 1 T1 minus T2 is W4. So you got all these expressions. Now to you, W1, W2, W3, W4. So efficiency, to find out what to do, I'll add all the works done. So final step. So total work done. What is total work done? W1 plus W2 plus W3 plus W4. What is W1? I am writing NRT1 ln V2 by V1. Okay, students. What is W2? NR gamma minus 1 into T1 minus T2. Okay, Anna? W3 plus minus work will get minus NR T2 minus NR T2 ln V3 by V4 you are getting, V3 by V4. Last step, minus NR by gamma minus 1 into T1 minus T2. You are getting total work done. Total work done you are getting. But this one gets cancelled. So total work done you are going to get NR T1 ln V2 by V1 minus NR T2 ln V3 by V4, ln V3 by V4. This is the expression work done you are getting. NRT1 ln V2 by V1 minus NRT2 ln V3 by V4. But you have to use one condition. V3 by V4 is equal to V2 by V1 we have to prove. How to prove that? I am showing here. Here I am showing one logic. I am showing you in the diagram. See in the diagram, students, if you see here diagram, if I am showing this diagram, I am moving down and showing you here. You show here what will happen. Adiabatic process or what? What are adiabatic process? Here, adiabatic process. T1 V2 to the power of gamma minus 1 is equal to T2 V3 to the power of gamma minus 1. T1 V2 to the power of gamma minus 1 is equal to T2 V3 to the power of gamma minus 1. Finally, T2 V4 to the power of gamma minus 1 is equal to T1 V1 to the power of gamma minus 1. You will get it. So that is what we are going to use. So, friends, already written, but once again I am writing work done. What is work done? I am writing students work done. IP90. Huh? పోయిందా అయిపోయిందా ఎక్కడ ఒక స్టెప్ ఉండిపోయింది మేడం ఒకటే ఒక స్టెప్ ఉండిపోయింది అయిపోయిందా ఏంటండి ఉంటుందా Alright, friend, I am writing work done is nothing but equal to NRT1 ln, friend, NRT1 ln V2 by V1 minus NRT2 ln V3 by V4. We are having. We can prove adiabatic, just last step, just 2 minutes. Adiabatic process. For adiabatic process, I am drawing B to C, B1, B1, T1 T1 V2 to the power of gamma minus 1. So B starting from temperature T1, B to C adiabatic. T1 V2 to the power of gamma minus 1 is equal to T2 V3 to the power of gamma minus 1 you will get. It implies that T1 by T2 is nothing but V3 by V2 whole power gamma minus 1. Similarly, if you take last one, T2 V4 to the power of gamma minus 1, you get T1 V1 to the power of gamma minus 1. Last DA process you will get. From this T1 by T2, I am going to get V4 by V1 whole power gamma minus 1. By equating both the things you will get V3 by V2 gamma minus 1 same, V4 by V1 you will get. Therefore, V3 by V4 is equal to V2 by V1. V3 by V4 is equal to V2 by V1. So instead of V3 by V4, you can write V2 by V1. V3 by V4, you can write V2 by V1. V3 by V4, V2 by V1. So here you are writing, therefore, work done is nothing but NR ln V2 by V1 common here, because V2 by, this is V3 by V4 also, you can write V2 by V1, and you will get T1 minus T2. T1 you can write T1 minus T2, NR into ln V2 by V1, T2 minus, this is work done. What is Q1? NR T1 ln V2 by V1. So what is F? This is W, initial general process. Efficiency is nothing but work done by Q1. When you do work done by Q1, what you will get? NR ln V2 by V1 into T1 minus T2 by NR T1 ln V2 by V1 you will get. So NR ln V2 by V1, NR ln V2 by V1 gets cancelled. Efficiency will get T1 minus T2 by T1. Therefore, efficiency is nothing but 1 minus T2 by T1. This is the derivation for Carnot engine, where T1 is called temperature of source, T2 is called temperature of sink. Okay, thank you students. With this, we completed all long questions from first year intermediate physics. So with this, all long answer, very short answer questions, short answer questions, and long answer questions are over. So next classes we will take second year intermediate physics, starting with very short questions from Monday onwards. Thank you. Speaker లేదా తీసేసాడా?